Here we'll take a look at another example of a quadratic equation in standard form. So we're trying to sketch the parabola. So again, we're going to start with that line of symmetry, and that's going to begin with this x equals negative b over 2a equation. So once more, y equals ax squared plus bx plus c is the coefficients in our standard form. So when we say we want x equals negative b over 2a, our b value is 2. So negative 2 is going to be in the numerator over 2 times, and then a in this case, there's a negative in front of the x squared, so a is negative 1. So it's going to be 2 times negative 1. So we're going to get negative 2 over negative 2, or x equals negative 2 divided by negative 2 is 1. So our line of symmetry is at x equals 1. So I'm going to go ahead and put in a vertical dotted line here at x equals 1. So I know that's the line that my parabola is going to be centered on. I also know that that doubles as the x-coordinate of my vertex. So I know that 1 is the x-coordinate. So to figure out the y-coordinate, I'm going to plug that number, that line of symmetry value, into my equation. So I'm evaluating my function at x equals 1. So I just have to be careful here. So I'm going to treat this as negative 1 times x squared. I want to make sure that I understand that that negative 1 is separate from the x squared. So it's negative 1 times 1 squared, and then plus 2 times 1, and then plus 8. So I have a little order of operations issue here. So I'm going to have 1 squared, which is 1, and then I'm going to multiply it by the negative. That's why it's important that we understand that that negative is separate from the x squared. So order of operations, 1 squared is 1 times negative 1 is negative 1, plus 2 times 1 is 2, plus 8. And so if we finish out the arithmetic here, negative 1 plus 2 is 1, 1 plus 8 is 9, and so we've got our y-coordinate of the vertex, 1 comma 9. So I'm going to go up here and make a dot. Now, as I mentioned in the previous example in the previous video, we can predict that this parabola is going to open downwards because we have a negative in front of the x squared. So we should anticipate that, and indeed we can see that the y-intercept, our c value equals 8, so that's our y-intercept. Remember, c is the number that's being added or subtracted that doesn't have an x attached to it, so our y-intercept is 8 to go along with our vertex that we had here. So that's going to give me a point right here on the y-axis. And so using symmetry, I know I have a matching point on the other side of my line of symmetry, so I've got a point right here. Now, these points clustered so close together doesn't give me a great picture as to what's going on with my graph. I'd like to have just one more point that I can use that will help me get a better sense of the width of my graph. And so we can plug in a number that is 2 to 3 points to the right, or 2 to 3 points to the left of our line of symmetry to help give us just a little bit more information. So since I've already got the points that are 1 unit to the left or right, I'm going to go 3 points to the 3 units to the left or right. So I'm going to go ahead and plug in 3. I'm going to evaluate my function at x equals 3. So I'm looking for what is the y-coordinate when x equals 3, just to give me a little bit more information. And so if I plug in 3, I'm going to get, again, negative 1 times 3 squared plus 2 times 3, and then plus 8. So if I finish out that arithmetic, I've got 3 squared is 9. 9 times the negative 1 gives me negative 9. Plus 2 times 3 is 6. And then we don't want to forget the plus 8. So negative 9 plus 6 is negative 3. Negative 3 plus 8 gives me 5. So I know my graph is going to go through the point 3, 5. So I can go over 3 on the x-axis, up 5, so I know I have a point right there. And then again, I can use that concept of symmetry, knowing that that line of symmetry cuts my graph into two identical parts. Well, if I have a point that's 2 units to the right of the line of symmetry at that y-coordinate of 5, then I know I have a matching one 2 units to the left of the line of symmetry. And so with that, I've got enough information to draw the sketch of my graph.